So this video is to give you a quick bit of feedback on a couple of the questions on the block 3 quiz that some people got wrong. So I just wanted to go through the reasons why that was. The first questions I'm going to look at are questions 17 and 18, which were another of these sequence questions. So what we did was we gave you the sequence of a gene. So the gene was malate dehydrogenase, and this was the DNA sequence that we give you. So it was malate dehydrogenase was the enzyme that the question was about. Actually, it doesn't matter what the gene is for this question, but what is important is to note that this is the DNA sequence that you were given. And we asked you for two things. So question 17 was the corresponding mRNA sequence, and then we asked you for the protein sequence for the first few. Okay, so this, when we give you a sequence, and it's a DNA sequence, if you remember, we give you that as the sense sequence. Okay, so just so to remind you, so if this is the DNA, I'm just going to draw this out again. So, so we've given you the sequence A, T, G, T, C, T, G, A, C, C, A. Off we go. So DNA is a double-stranded molecule. So the other strands of the DNA would be T, A, C, A, G, A, C, T, T, G, G, A. And off we go. Remembering that A pairs with T with 2 hydrogen bonds and C pairs with G. So that's how we get those sequences. Okay, but you actually, we're not asking you for the DNA sequence, we're asking you for the mRNA sequence. So let's think about what happens in transcription. So usually in DNA, those two strands are together, but when we have transcription, we have the DNA double helix. So there's the double helix, it splits, and we have what was called a transcriptional bubble. So we've now got those two strands separated. So TAC, AGA, CTT, CCA. So that's exactly the same thing, but the two strands are separated. And of course, they come back again at the end of the bubble. So the question was, what's the mRNA sequence? Well, mRNA, we remember C pairs with G as normal. But A, which would usually pair with T, A would pair with U. Okay, so let's work that through. So we start with a T. Well, T's pair with A's still. Okay, so T pairs with A, but A would usually pair with T, but we're making an mRNA molecule, so that's a U. C pairs with G, that's unchanged. A would usually pair with T, but it's an mRNA molecule we're making, so it's a U. C, U, G, T usually pairs with A, and that's fine. We can still have A's in RNA. So we've got that sequence. So our mRNA sequence is AUG-UCU. So you'll notice it's the same sequence that we had before, but it's swapped out the T's for U's. Okay, so some of you gave me UAC-AGA-UTT. That's a molecule that doesn't exist. So the answer was AUG-UCU. So it's the same sequence, but we swap out U's for T's for U's. So that was in transcription. We then asked you to use the genetic code to translate that sequence, and we wanted the first 3 amino acids. So if you remember, the translation works as we always need to give we work in blocks of 3 because each one is a codon. So AUG gives us the amino acid methionine. UCU gives you the amino acid serine. GAA gives you the amino acid glutamate. But we asked it for a single amino acid code, so the answer should have been MSE. So that was the correct answer. A few of you gave me a slightly incorrect answer, so you got a little bit confused with the last amino acid, but that was understandable given the way that I presented the question. So GLU is glutamate, which is an E. But some of you got it confused with a couple of other amino acids. So some people got it confused with glutamine, which was a Q, and some with glycine, which was a G. But given that I didn't give you a table of those lookups, I thought that was an understandable error, so I gave you the marks anyway. So it doesn't matter whether you gave me an E, a Q or a G there, you got the points on the question. Okay, so that was the answers to questions 17 and 18. The other one that I'll just go through quickly was question 22. Which was a Beer's law question. Okay, so the question was to calculate the concentration of NADH at a 3-minute time point. So we gave you a table of values using Beer's law, and we gave you the extinction coefficient of NADH, which was 6220 moles per centimetre, and the path length, so how big the cuvette was 1 centimetre. So this is a Beer's law question, so we know that A equals C epsilon L. So remembering that A is absorbance, C is concentration, L is the path length, and E is the extinction coefficient, which is basically just a conversion factor. Okay, so if A equals C equals L, well, we know the value of A that you were given in the question was 0.362. So now we know A, we know A epsilon, we know L, so we're trying to find C. So if we rearrange that, C equals A over epsilon L. So now we can substitute in the values, 0.362 divided by 6, 220 times 1. So that gives us an answer of 0.0000582 molar, but the question asked you for it in micromolar. So to go from molar to micromolar, we need to times by 1,000,000. So therefore, if I times that answer by 1,000,000, I get an answer of 58.2 micromoles, micromolar NADH. Canvas was a bit funny with some of the rounding, so some of you I've manually rescored that, but as long as your answer was 58 point something, you got the points for that question. Okay, so that was how we did it. We went through Beer's law, substituted in the values, and then went from molar to micromolar by timesing by 1,000,000. So if you got any of those wrong, hopefully that's given you a hint as to what you did wrong. If you want to ask any questions, then please just drop me a message if you still don't understand why you went wrong, but hopefully that's helped you out a bit.